Welcome to part 2 of our tutorial series on using the environment editor. In this tutorial, I'll be focusing only on using volumetric fog, both globally and in local fog volumes. This tutorial presumes that you're already familiar with the concepts that were covered in the first tutorial in this series, so please take a look at that if you haven't already. I also suggest that you look at the written versions of these tutorials here in the documentation, as they go into more detail than there's time for in the videos. In part 1 of this series, I went over the 3 biggest components of the environment editor: the sun, the sky, and fog. Up to this point, we've only used the old fog effect. But from this point forward, we're only going to work with volumetric fog, because that's the workflow we recommend. Volumetric fog is voxel-based and uses volume textures as a view frustum-shaped voxel buffer, which I think you'll agree sounds pretty impressive and that most of us have absolutely no idea what it means. But fortunately, all you need to know is that volumetric fog just looks much more realistic than the old fog effect. It also supports many more features with less complicated names, including dynamic shadows, ambient light, and variable density. So let's see how it works. I'll be using CRYENGINE 5.6.5 for this tutorial, so if you're using a much older or newer version, you might see some differences in the interface. It's also useful to search the release notes in the documentation to check when specific tools have changed. So I have a simple level that just has some terrain and vegetation to cast some shadows. And I'm going to create a new environment preset, so we start with the default values, and I suggest you do the same. As I suggested in the last video, the first things you want to do are to set the HDR eye adaptation mode to be compatible with CRYENGINE 5 here in the console tool, to desaturate the HDR color balance so it isn't making everything yellow. And since I'm not working with dynamic time of day, I'm going to leave the time of day at 12 noon or whatever standard your studio has decided on. Ignore the curve editor, unlink the sun settings from time of day here in the constants, and just quickly lower the sun in the sky to 30 degrees so our shadows are a bit more useful. Next, volumetric fog is switched off by default. To enable it, go to your console tool, which you'll find in the menu under Tools, Advanced, Console, and type E_volumetric fog space 1. If you've made a bunch of changes to your fog settings, everything might suddenly look very different, but don't panic, it'll all become clear. Or foggy, but in a good way. Next, you'll notice that when you enable volumetric fog, it disables the old fog effect. As you can see, these controls now do absolutely nothing, which is good. However, there is an important exception to this, which is that these top color values interact with SVOGI when you're using it. Now I'll cover SVOGI in the third tutorial in this series, but for this tutorial, please leave your SVOGI off. Enabling volumetric fog in the console activates global volumetric fog, which is controlled exclusively through these variables in your current environment preset, but they're also controlled through some console variables that I'll talk about at the end. It also allows you to use local volumetric fog volumes, which you'll find here in the Create Object tool under Components, Effects. Now there's nothing to stop you from placing fog volumes in your level, but unless you enable volumetric fog at the console, they are not going to look right at all. So I suggest that if your level depends on volumetric fog, put E_volumetric fog equals 1 in your autoexec.cfg file or your .cry project file. And you can read about those startup files in the documentation right here. Now before we take a look at these local fog volumes, let's talk about the volumetric fog settings in general. I'm going to collapse the old fog variables so we can just focus on the volumetric fog settings. Although there's really nothing to indicate it, these variables actually fall into 3 types. Everything from the top down to radial blend mode only affect global volumetric fog. There's nothing here that says it's global or that such a thing even exists, but trust me, it does. These 2 variables, which are labeled entities, only affect local fog volumes if you have any in your level. And then these last 5 affect both global and local fog. They're like the master controls for all fog of all types, forever and ever. Now, if you've looked at the old fog effect or watched the first tutorial in the series, a lot of the volumetric fog settings are going to be familiar. You have global density, bottom and top height and density, sun radial color, and ramping, most of which we already discussed. One immediate difference you might notice is that while the old fog effect has separate color swatches for the top and bottom of the fog range, volumetric fog just has one swatch for the whole range called Color Atmosphere. This sets the albedo color of the global volumetric fog which, as you can see, can be any color you like, even hot pink, if that's how you roll. Now, in fact, if realism is your goal, I don't recommend tinting your global fog color unless you're trying to simulate the effects of a recent volcanic explosion or something magical, which is perfectly possible given that we're designing games, because lights have colors, and those colors should be caught by the fog. In other words, unless you're making radioactive, purple, glowing, venomous, angry fog from planet Zichgorth. Again, perfectly likely. Fog is simply moisture in the air, and it just picks up the color of the light that strikes it. It usually doesn't have its own color. Sorry, Zichgorthians. But in the interest of imaginative game design, you can use color atmosphere to do any crazy thing you like. Boom! You may also notice that the default top height of volumetric fog is 4,000 meters, whereas the default top height of the old fog effect is 400 paltry meters. Now, that's neither here nor there, since you can set this to anything up to 30,000 meters, which happens to be 3 times as high as the uppermost limit of Earth's atmosphere. But this difference in the top height between the old fog and the new fog is one reason the world usually looks kind of different when you switch between the fog systems. So one of the first major challenges of using fog is that there is no way to keep the global fog out of your buildings, out of your interiors, even though in real life that doesn't really happen, I don't think. Now, the shortest piece of advice I can give you is simply to keep your global fog density low enough so it doesn't look ridiculous indoors, and use local fog volumes wherever you need more density. You can also use the ramping settings here, ramp start, ramp end, to limit the fog right in front of the camera, but this does have some limitations. Here's an example. I've placed our old friend the hangar from the free Game SDK sample project in my level. This building happens to be about 32 meters long by 20 meters wide, and I've positioned my camera at one end of the building so I can see its full length, and I've set my global fog to be really dense and really colorful so it's really easy to see. Now, if my ramp start and end values are 0, then I see fog everywhere with even density, including inside the building. But if I set ramp start to 15 meters and let the fog reach its full density at 30 meters at ramp end, things look a bit better. I see some fog creeping into the far end of the hangar, which might be perfectly fine. That's a really big door. And remember that these ramp values are the distance from the camera where the fog density begins to accumulate and then reaches full density at ramp end. When I say full density, I mean whatever value you've set in your global density parameter. Now, if I tweak these values a bit further away, starting at 30 meters, which is about as far as I'm seeing in the building here, and achieving the global density value at 50 meters at ramp end, things look pretty good. In other words, as long as any single room doesn't let me see further than about 30 meters in this case, things are fine from the inside. But ramping doesn't help if I can see into the building from the outside, because as soon as I move the camera more than 30 meters away, in this case, I have foggy building syndrome all over again. So ramping's fantastic for basements and top secret government bases and serial killer houses and any other buildings without windows, but otherwise it's kind of limited in its usefulness. So what do we do about this? Like I said, keep your global fog density low enough and maybe use a bit of ramping, but if you do want to have global fog or any fog and you want to keep it out of your buildings, then you need to use fog volumes in the level. And you need to constrain where the fog appears using clip volumes. Now, I covered how clip volumes work in this lighting tutorial, and it's the same with fog, but in case you haven't watched that, I'll quickly go over the steps and introduce you to fog volumes at the same time, and I'll do it with just 10 fingers. I'm going to drag a fog volume next to this greenhouse using Create Object, Components, Effects, Fog Volume, and I'm going to set the box size as 20 by 20 by 10 meters, and again, I'm going to make it very dense and, bright red so you can easily see it. So how do I keep it out of the greenhouse? Even though, well, in real life, greenhouses are usually more foggy than the world around them, but let's just pretend it's a very dry greenhouse, all right? Because glass walls are convenient for purposes of seeing what's going on inside. So the answer is simply to draw a clip volume that's shaped like the building. Go to Create Object, Area, Clip Volume. Don't worry about getting it exactly the right shape in the beginning because we're going to edit it anyway. And once I have my box, close the tool, very easy to forget. Now, I need to modify the clip volume in this case to have a sloped roof, and I might need to move some polygons around to match the size better. So I click on this Edit button in Properties, and since clip volumes are designer objects, I'm going to use the Designer tool to add a loop cut, I'm going to grab this top edge and use my move tool to pull it up to slope the roof. Now, if you need to, you can grab the other polygons and pull the walls around to make sure it's about the same size as the building. But in truth, fog has soft edges even if you set the softness to 0, so it doesn't need to be a perfect match. It's a little trickier with lights where you kind of need the clip volume to be inside the walls to have the light on the walls, but not short of the walls, if you know what I mean. Close the designer tool and voila, there's my clip volume in all its glorious blueness. Now I'm going to turn off the filled property so I can actually see what's inside it with my helpers on. Now comes the important part. There are two things you can do with clip volumes. You can use them to exclude lights or fog, or you can use them to include or constrain lights or fog so they only appear inside the clip volume. We want to exclude my red fog from the green house, get it? So the first step is to make sure that the fog's pivot is not inside the clip volume. Very important. Not inside the clip volume because we want to exclude. Next, we need to use the Entity Links tool to link the fog to the clip volume. And don't forget to close the Entity Link tool after you link, or else you'll be linking forever and ever. Lastly, we just need to make sure that this property only affect this area is enabled. And now if we move the camera inside the greenhouse and look around, voila, no foggy. Now if you don't see this happen immediately, I've noticed that sometimes you have to toggle the active property of the fog or lights off and on again to force an update, although I think I've only seen that behavior with light components. So you could even do this with a fog volume that covers your whole level. In other words, a fog volume that serves as your so-called global fog, or even beyond the height map. What you need to do is create clip volumes inside all of your buildings where you don't want fog to appear. Link any fog volumes that you don't want to appear in those buildings to each of the clip volumes, just like we did here. And like magic, no fog inside your buildings. Just don't forget, only affect this area has to be enabled. Now, while we're looking at clip volumes, if you are in the greenhouse business or just want to model a smoky bar, you can constrain a fog volume so it only appears inside the clip volume in even less steps. The difference is that to include, you simply put the fog inside the clip volume. So just for a quick demo, I'm going to drag the red fog inside the clip volume, specifically the pivot of the fog component, inside the clip volume, and voila, I have a red house instead of a greenhouse. And of course, the only affect this area property must be enabled. Otherwise, if I turn it off, the fog will just simply fill the area set by the box size. So actually, limiting fog to a clip volume is even more simple than excluding it because you don't even need to link the fog to the clip volume. Just place it inside it. I'll prove it to you by removing this entity link, and as you can see, I still have my foggy red house. Excellent for growing exceptionally juicy tomatoes. Tomatoes. Another interesting thing that you can do with fog volumes is to make them emissive, although I put that word in quotes, because in fact it just makes the fog self-illuminating. Fog never actually emits light. To do this, you need to bring this emission intensity up past 0, and you need to click on the emission swatch here and set the luminance higher than 0. Now in truth, this is kind of like a light switch. 0 is off and anything 1 or higher is on. Voila, self-illuminated fog. I'll prove that this doesn't actually illuminate anything except itself by turning my sunlight intensity down to 0. Remember that the sky in CRYENGINE doesn't emit any light, so that's not why we're seeing the fog. Now you might think that if you've set the color property to something colorful, like my fog, which I'm going to set to a radioactive green for no reason whatsoever, you might think that this emissive light will be in that color. But that is the albedo color of the fog, and that only gets revealed by an external light source, like sunlight or light components or environment probes. Now I'm going to turn on a projector light that I just happened to have placed to shine through the greenhouse. It's got a very narrow beam, and as you can see, the projector light is white, as you can see from the color of it on the terrain here. But where it's hitting the fog, it's the albedo color that I set for the fog, which is green. And now to make things even more fun, I'm going to add some saturation to make the emissive color a cheerful magenta, because I happen to know that cheerful magenta fog is going to be all the rage next year. And now you'll see that the projector light is revealing the albedo color of the fog, but otherwise the fog is illuminating itself in cheerful magenta. So I've got two different colors going on here, and this will really impress your friends. They'll want to know how you did it. And just a reminder, any color that you assign to your light, whether it's sunlight or a light component or even environment probe's diffuse color, that color will get mixed with the fog's albedo color. That's going to be impossible to see with this crazy color I have at the moment, so I'm going to desaturate the fog's albedo color and then set the projector light to a different color. As you can see, whatever color I choose gets mixed with the fog's albedo color. So just don't mix two completely opposite colors that are 100% saturated, or for some strange reason they just cancel each other out and you see no fog at all. Sad. By the way, you may notice that the emission swatch kind of acts a little bit strange in that even after you pick a color, it may still show what looks like a black swatch. Now that's because the swatch appearance is also affected by emission intensity, and I'm using quite a low value. If I bring that up, the swatch reflects what it considers to be the emissive color a bit more accurately. But at very low intensities, it tends to look black, even though that's not how the fog actually looks. C'est la vie. The global volumetric fog works exactly the same way, but as I said, its albedo color is set by this color atmosphere property. Now, one more thing about the albedo color of fog volumes. You also have the option of enabling this use global fog color property. And if you do, that fog volume's color property is ignored, and it uses the color set here in the environment editor under color entities. This is useful when you want to control all or many of your fog volumes from the environment editor, in other words, globally. And now, the moment you've all been waiting for. It's time to talk about anisotropy. Woo, yeah! Actually, this is one of those very fancy technical sounding words for something you can see very easily. Anisotropy means how direction-dependent light scattering is, and in which direction. So let me demonstrate with light scattering in the global fog, which is controlled by these two values right here, anisotropy sun radial and anisotropy atmosphere. I'm going to demonstrate using the sun radial because it's pretty easy to see. I'm going to set the color to a fairly saturated orange so we can just see it really easily. Now the anisotropy settings go from -1 to 1. +1 means the light is scattered in a forward direction. In other words, the same direction as the light is traveling. If you look around, if you can find some fog and some light, or just do a quick online image search, you'll quickly see that atmospheric fog is easiest to see when the light is facing you. In other words, when the light source is backlighting the fog from the opposite side from where you're standing. For instance, you might have seen sunbeams in a dusty room, and you'll notice that it's easiest to see them if you get close to the light beams and look right down the axis almost directly towards the sun. But don't actually look at the sun because it's just not worth it. Now, if you stand on the same side of the fog as the light source, you don't see as much scattering. In the environment editor, a positive anisotropy value gives you this normal kind of scattering, which we call forward direction. Values close to but not quite 1 will work out best if you want to kind of confine your scattering around the sun. But if you really want to create otherworld craziness, you can use negative values right down to -1, which will scatter all of the sunlight in about the size and shape of the sun, but on the opposite side of the world from the actual sun. So I think we can agree that we should throw a party for the first person who thinks of a reason to use backward scattering in a game. If you set anisotropy to exactly +1, the scattering is 100% in a forward direction. And what that means is it overlaps the sun orb itself, so effectively it just disappears. Now, if you want to eliminate the direction dependency of light scattering and just throw it around in every direction like the reckless maniac you are, just set anisotropy to 0. When I set my sun radial anisotropy to 0 and pan around the horizon, you see that sun radial color is scattered evenly all the way around. Generally, you're going to want to use a positive value closer to 1, but it's a bit of a creative decision. Anisotropy entities does the same thing, but it only controls light scattering and fog volumes. There is a bunch more to what you can do with local fog volumes, most of which is pretty straightforward and you can read about in the documentation. I do want to draw your attention to the fact that environment probes and light components have this property called affect volumetric fog, as well as only affect volumetric fog, so you can control whether they affect fog or not. You can use this to have your environment probes throw ambient light into volumetric fog, although I usually find it more useful to leave it off. A few useful and unique features that I'd point out about fog volumes are the ability to control falloff, the edge softness, you can even crank that down to 0 and have like a hard block of weird fog, like a fog creature, I don't know. Ramping, which we already talked about, and how strongly the global wind influences each fog volume. I think the most useful thing is probably this ability to add noise that can vary your fog density dynamically and kind of give your fog a more organic quality. Check the documentation about recommended values though. Okay, let's take a brief look at some of the environment editor settings that affect both the global and the local fog. In-scattering sets the overall level of light scattering. If you set it to 0, you completely eliminate all light scattering, effectively making all fog magically disappear. Again, if your game is set on the moon, or an asteroid, or an unusual planet with no atmosphere whatsoever, this would be one way to simulate it. I'd probably not recommend using it as a kind of volume control for your fog, but use global density instead. Extinction is the combined effect of light scattering and absorption by the atmosphere. When light gets absorbed, it's transformed into another kind of energy in the real world, but effectively it just reduces the light that you see. Raising this value is going to attenuate the light trapped in the atmosphere, but it's not even everywhere. As you can see, it's going to be most noticeable on the opposite side of the sky from the sun. In most cases, I would just leave it at the default value. Final density clamp can be used to set the limits of the sum effect of all your fog settings from 0, which is completely invisible, to 1, which is 100%, full strength, or essentially leaving your settings play out without any last stage attenuation. I would recommend approaching these last two parameters pretty conservatively and test them thoroughly because they're going to have a profound effect on all of your other fog settings. So I'd probably leave them at the defaults, get all your fog settings set up, and then if you're still not getting what you want, you can come play with these. Last but not least, range. This will need to be at least as big as your biggest fog volume size setting in its transform properties, in other words, the biggest dimension of any one of your fog volumes, in order to see it in its entirety. Realistically, that doesn't usually happen unless the player is somehow at a high vantage point so they can see the whole fog volume at once. However, there can be some performance cost to this, so I do recommend that you read the documentation page on volumetric fog here for some tips on recommended values. The last thing I want to point out about volumetric fog is that you'll probably want to fine-tune the actual voxelization of the fog at some point. At the default values, which I have here, you're likely to notice the voxelization itself, which probably isn't what you want. It kind of looks like old analog TV static to an old person like me or anyone old enough to actually have seen analog TVs. To adjust it, you use two console variables. R_volumetric fog text depth specifies the number of samples. The higher values will give you smoother, less voxelized looking yummy fog. You'll find the values above 200 will be unstable and produce crashes, so I recommend values in the 32 to 180 range. Then R_volumetric fog text scale controls the size of those fog samples. Lower values will give you sharper fog and fog shadows, less obvious voxelization, but here you need to avoid values below 3, which become exponentially more expensive and unstable. I recommend values in the kind of 6 to 15 range. So here's what my fog looks like with R_volumetric fog text depth set to 120 and R_volumetric fog text scale set to 8. And that is it. I hope this tutorial has made things less foggy for you when it comes to volumetric fog, or more foggy, but in a super clear, intentionally foggy kind of way. You can find more information about volumetric fog here in the documentation, including additional cVars, recommended settings, and some examples. In the next part of this environment editor tutorial series, I'm going to go over additional concepts including SVOGI, volumetric clouds, and HDR, and we'll finally bring all of these settings together in a whole bunch of use cases that are very practical that you can download and try out. And I'll include some very naturalistic settings like sunrise, midday, cloudy days, and some purely crazy, fantastical looks. Happy fogging!